So when revising, remember that if air masses with different characteristics collide, they do not but form a front which develops as a line separating the two air masses, and the area along which the two air masses meet is called a frontal surface. And we have different types of fronts, which include a warm front, a cold front, occlude front, and a stationary front. And a cold front is a front in which cold air is replacing warm air at the surface. A warm front is formed when warm air and cold air meets, and they do not mix. Warm air rises over the cold dense air. A stationary front develops when polar air masses are modified greatly and lose their character. Occlude front, this occurs when cold front catches up with warm front. The cold air forces the warm front up. It is formed when a cold front moves faster than a warm front and overtakes it. Now let's move to the intertropical convergence zone, the ITCZ. Now, the ITCZ is a belt of low pressure where the winds or the trade winds in the northern hemisphere and the southern hemisphere meet. It is called the equatorial convergence zone, and it shifts north and south seasonally with the sun. The intertropical convergence zone brings about cloudy weather, heavy rainfall, and frequent thunderstorms. It is an area or zone of low pressure within the Tropic of Cancer and Capricorn, where different air masses with different characteristics meet, resulting in rainfall. Now, the air masses which operate over and around July. So we have air masses which operate over and around July. So the intertropical convergence zone is part of the worldwide weather patterns between the latitude 30 degrees north and 30 degrees south. Variations in the locations of the ITCZ drastically affect rainfall in many equatorial nations, resulting in the wet and dry seasons. So the shifting of the ITCZ is the result of the Earth's rotation, which is thermal position, axis inclination, and the transition of the Earth around the Sun. So seasons are the results of these movements. Now we're looking at the weather associated with the ITCZ in winter. So the northern hemisphere experiences their winter period in January, and the southern hemisphere experiences their winter in July. So the Köppen climate classification system is widely used for classifying the world into climatic regions based on the annual and monthly averages of temperatures and precipitation. 5 major climatic regions emerge from the Köppen classification, and these are: A, the tropical moist climate. They lie about 15 to 25 degrees of latitude. The average temperatures exceed 18 degrees Celsius per month. The annual precipitation is above 1,500 millimeters. And examples of countries that experience this type of climate include Equatorial Guinea, Cameroon, Nigeria, and others. B, dry climates. These have a deficient precipitation during most of the year. They lie 20 to 35 degrees north and south of the equator. Countries include parts of Botswana, parts of Namibia. Moist subtropical latitude climate, which is C. It is found between 30 to 50 degrees north and south of the equator. It has mild winters in which high rainfall is experienced. Summers are usually dry for up to 5 months. D, moist continental mid-latitude climates. They have warm to cool summers and cold winters. The average temperature for the warmest month is above 10 degrees Celsius, and the coldest is less than -3 degrees Celsius. Then the last one, which is E, polar climates. They have extremely cold winters and summers. They experience low temperatures throughout the year. The soil is permanently frozen, that is permafrost. The vegetation mainly consists of mosses, lichens, dwarf trees, and scattered shrubs. Examples include Iceland. So, in these 5 major climatic regions that emerge from the Köppen classification, we are talking of 1. Tropical moist latitudes, 2. Dry climates, 3. Moist subtropical latitude climate, 4. Moist continental mid-latitude climates, and 5. Polar climates. Now let's look at the factors influencing climatic regions. There are a number of factors that influence the world climatic regions, and these include 1. Latitude. When the Earth circles the Sun, the tilt of its axis changes in the angle at which the sun's rays hit the Earth, and this changes the daylight hours at different latitudes. 2. Surface of the Earth. The amount of sunlight absorbed or reflected by the surface of the Earth determines how much heating takes place. Darker surfaces absorbs heat, and light surfaces tend to reflect heat. 3. Distribution of mountain barriers. The position of a place and its distance from the mountains helps determine prevailing wind patterns. Mountain ranges are natural barriers to the movement of air. Remember, when air is barred from moving, it is forced to rise. This results in orographic rainfall. Now, patterns of prevailing winds, which is the 4th one. In the northern hemisphere, there are 3 major wind patterns, and in the southern hemisphere, there are 3 major wind patterns. The wind patterns shift north or south as seasons change. The intertropical convergence zone moves back and forth across the equator. Then we have altitude, which is the last one. This is climatic conditions become colder with an increase in altitude. No trees grow on mountain summit, but the plants at the base are the same as the surrounding countryside. So what are the factors? When you're looking at the factors affecting climatic regions, we are looking at latitude, the surface of the earth, distribution of mountain barriers, patterns of prevailing winds, and altitude. So these are some of the factors that influence the climatic regions of the world. Follow our Facebook page, Survey Scholars Academy, and also don't forget to like and share our YouTube channel, Survey Scholars Academy. And also for your online sessions, you can directly contact us on +263 782 108 484. Thank you.